have time for questions and answers at the end. If you have questions while we go along, please put it in the chat box and we will definitely deal with that later. At the end, I'll tell you a bit more about AFBE and our upcoming events. Just a bit about Serica Energy. So they're going to show us through the Boost platform in the North Sea, using a state-of-the-art technology, which enables them to walk through the full digital facility with a Google Map style way. Serica Energy is UK's organization with an operation based in Aberdeen, with 80% of their production in natural gas, which is a key element of the UK's energy transition right now. Just a bit about a speaker as well, Bruce. He has over 24 years experience in oil and gas, and it's been involved in services, manufacturing projects and operation. He joined Serica Energy in 2018 and has transitioned since then. He's a chartered mechanical engineer, a member of the Institute of Mechanical Engineering. And I will just pass it on to Bruce now. There you go, Bruce. Thank you.
Thank you. Hi, it's Bruce speaking. So this is my presentation on the Bruce digital twin. So thank you everybody for joining and attending this. I'm a mechanical engineer and I'm responsible for the static equipment on the Bruce asset. So I'm going to be giving an overview of what we call the digital twin of the Bruce asset, and talk through and show some of the benefits that we are now seeing through the everyday use of this technology. There are some short videos that gives demonstrations of the tool throughout the presentation, and we'll also share my desktop and just show me operating the GDI software itself, and point out a few areas and just show some of the functionality of it. There was a few proposed outcomes for the presentation. The three of them, they were to give just a general understanding of the asset, from how the oil and gas comes out of the ground and gets to the pipelines. An understanding of how the technology can be used and applied in the real world to help with engineering and communications, and to provide an understanding of how laser scanning works.
Sorry, Bruce, I can't see your screen. I can only see your name.
Okay, I've just flicked to the next slide. Can you see there's a new slide up saying about Serica? Is that?
Yeah, we can see it. Yeah.
Okay. So just a short slide about Serica. We are a British independent upstream oil and gas company, headquartered in London, and we're focusing on the North Sea continental shelf, the UK continental shelf and North Sea. The Serica operates the Bruce Keith Rum fields through the Bruce asset, which is something they acquired from BP in 2018. I transferred over with the deal, and had been at BP for 6 years prior to that. The net production for Serica was around 23,800 barrels of oil equivalent a day. We've also got interest in the Erskine field, and we operate the Columbus development, which is due to come on stream later this year. Okay, this next slide is just a brief bit about the Bruce. Can you see this slide okay, just as a double check?
Yes.
Yeah, cool. Yeah. Okay, so the Bruce was called the last of the dinosaurs when it was being developed, due to the scale of the asset and the project. Bruce was discovered in 1974, and the project was sanctioned in 1989. And phase one of the development cost around 1.2 billion. First oil was in 1993. Center of the screen shows the pipelines back to shore. The asset is located about 400 kilometres northeast of Aberdeen. Gas is exported through a 32-inch pipeline. to St Fergus, and the liquids through 24-inch pipeline via the Unity unmanned platform to Cruden Bay. Peak production was 530 million cubic feet per day, and oil was 80,000 barrels per day in its heyday. So a little bit about the asset. This is Bruce 1.0, the physical asset. It comprises of 3 jackets, bridge linked together. The PUQ, marked in the blue over on the right hand side, this is the accommodation, where we can accommodate 156 people. That's based on lifeboat capacity. There are actually more beds. And this is where the oil and gas export pipelines reside. We also have power generation here, and this is where you arrive and depart from the platform. The drilling platform, this is in the centre. This was built first, and this is the arrival point for the Bruce oil and gas. You can see the drilling derrick towering there in the middle, and this is where well intervention is located. The CR, this is the compression platform. This was like phase 2 and came along later. And this is the arrival point for the rum gas and the booster compression for Bruce gas. And there is secondary helicopter access here for emergency use. Okay, so if I yeah, a couple of notes here. Just the PUQ jacket is in 121 meters of depth, and when it was lifted in place at the time, it was a world record for the heaviest jacket lift, which was 9,360 tons. The flare, you can see towering there as well. That was the world's highest at the time as well, which is 80 meters high. So we'll talk a little bit about laser scanning. This is how our digital twin was built. So it's created by laser scanning. And basically it's a scanning device that shoots out lots of lasers in all directions and records how they bounce back to the device, and it collects all these data points. This allows us to map out how far away the objects are and their shape as they each bounce back. And when you take enough scans, you can capture all the surfaces. You can create a 3D model. So this is how it was done. We sent the company off, GDI offshore, to scan the asset with our laser scanning, and this is a fly through of the PUQ asset of the model when it's all integrated together. So this is landing on the heli deck. So the PUQ is the largest of the 3 platforms of Bruce. The process works by rapidly scanning an environment from a fixed location and then capturing all the minute detail from all the surfaces and the surrounding objects. This is all collected and images taken, and then it forms this 3D model that you see. It took around 40 days to scan the facility in full by one person. And they had about 6,000 different separate scan locations, and it took about 190 billion points of data. So it looks good, but so yeah. So what do we do with it? So yeah, you can see the 3 digital scans of the 3 jackets there, but the case for this digital twin was so we could have a tool that could be used every day by both onshore and offshore teams to aid communication. it was to encourage different ways of working, enhance our onshore planning capability, and also to reduce the need for site visits, for surveys, for example. And we wanted a different approach for visual inspection, and with the aim of increasing work efficiency, so we could execute more work offshore. And it was to support our response to the COVID restrictions. As I mentioned, we had you saw the POB earlier, which is the max personnel on board, it was 156. Because of the COVID restrictions, we are currently taking 110, so that's had an impact on how much work we can actually carry out. The data itself amounted to 15 terabytes of data, and I'm told that equates to about 22,000 episodes of Game of Thrones. So this is an overview of the Bruce process. Where's my pointer? Sorry, just over on the left here, these are all the well slots, the manifolds, go through the process to the separators. It separates the hydrocarbons. We've got various booster compressors, and over on the right, this is where we've got our gas export and oil export. I mean, it looks fairly straightforward when you look at this, but and when just focusing on in this little area here, the manifolds, and I'm going to show you this piece here as well. This is all the wells. So for something that just looks fairly simple there, when you use the tool, it looks quite different. So if I show you the well area, so this is the software itself. It's called GDI Vision is the name of the software. Oh, it's taking a bit longer than usual. Okay, so when I go into a certain location, I save the bookmark to save time, and you can walk around and have a look. So these are all the wells, and you can zoom in, zoom out. You can go to these camera icons, and then that'll take you to the next data point. Now, I mentioned around there was about 6,000 different data points. This is one of the data points here. This is where the tripod would have been sighted and did the scan from. So it lets you move around 360 and just look around like that. You can zoom in quite far, zoom out. It's got the functionality to take measurements, which I'll demonstrate as well. Here's another area. So these are all the wellheads. So something that looked like just a little box on the overview I gave you all. It's quite complex. A lot of valves, a lot of pipes. So when certainly somebody who's unfamiliar with the asset or new to oil and gas and they see a schematic diagram, it looks fairly straightforward, but in reality, it's quite different. And this is what I'm trying to get across here. The next slide here is just a couple of the points to go to. Heli deck. So this is where you would arrive. Come off of the chopper. and you can see the data point here, the shadow of the scanning tool. So you can go to the plot plan of the asset, pick a point of interest, or you can just use it like you do in Google Street View. Just click on an icon, move to the next stage, and just walk yourself through the platform. You can do this, just walk around. So that's around about the helideck and manifold area. So that loads up. Next. Yeah, so just giving you a little look here. These are all the this is the manifold, and these are all the valves that are coming off of it. So you can see that there's quite a lot going on. These are all the choke valves. These are the valves that control the hydrocarbons when they come out the Christmas tree and reduce the flow rates and pressure down before it goes on to the separation. So one of the most obvious benefits that a dimensionally accurate digital twin brings is the ability to support rapid design and fabrication activities. So this is going to be a video. It's going to demonstrate how the digital twin can be used to support a rapid response for replacement of a spool. So this is the spool in GDI Vision, similar to what I just showed from my desktop. So the point cloud data can be extracted and loaded up into AutoCAD, and they start generating the model. Some of this is through artificial intelligence. There's the flanges. So traditionally, if we was to do this, we would have to mobilize personnel and equipment offshore, and need the time to complete a scan, and then a time to process the data, and then create drawings for this. So with a millimeter accurate model of the asset in place, we can now rapidly respond and produce construction drawings and commence fabrication within hours and not days in response to any emergent issues. It's not just for rapid repairs. The digital twin minimizes or it can eliminate the need for surveys for routine repair orders and modifications. From the AutoCAD model, the GDI are able to produce a fabrication drawing, and we can send that to the fabricators to proceed manufacture. So this next video shows how we can use it to understand and help to plan complex replacements. So this one was for a glycol line, and you'll see how complex this is. And the tool has enabled us to plan and design modifications from the beach without the need to go offshore and survey. So just imagine how long this would take to go offshore and survey. So this is the line in question. It's highlighted in green. It goes down through deck penetration, down another level, goes round down again, you can see the pipe supports here as well, how it's supported. So this is made up of numerous bits of pipe. There's lots of connections there. There's another deck penetration. To go offshore and survey this would have been quite significant, and we were able to get this model pulled from the digital twin in no time at all. So this digital twin is allowing a rapid response and modifications. It's allowing us to specify replacement pipework remotely without the need for surveys, or minimising how much surveys we need. It's allowing us to plan modifications from the beach, and it's allowing us to react faster and respond to issues as they arise. So the next couple of slides is around learning and planning. So while this video plays, I will give a talk through. It's been quite pleasing how the asset images have captured everything during the 3D survey, and it's become an everyday reference point in communication aid that's been embraced by the offshore and onshore teams. The support in GDI Vision software allows the users to access a scan location and navigate through the facility and points of interest. In its most basic sense, it offers a remote asset familiarization capability for those who have never been on the Bruce asset. So this is really useful for first-time visitors who's never been there for familiarization. And what you're seeing here just now, this is a 3D model, a different database that was produced in the early years of the asset, and this database has been able to be incorporated into the model. So you can integrate other databases into the GDI software, which we're still realizing the benefits. So so yeah, for it really minimizes the time needed to do a survey. It's helping us to plan jobs. Before people even mobilize to the asset, we can give them a walk around, show them the locations, the point of interest, and it's been helping us get some queries addressed before we even get there. When I used to go offshore and do surveys for various scopes, sometimes I just got told my check-in details and had to go offshore, and you'd find out when you got there. And it would have been so useful to have had this at the time to familiarise yourself and start preparing. It would have been a lot more effective. So that's within the GDI software. It does enable you to tag equipment and add comments and defects. So we've started using this now for equipment identification and defect tagging. So when planning a repair, the location can be identified in the model, measurements are taken, and the work estimated and prepared. The dynamic links within the GDI software enables the navigation to correspond with a corresponding work order in Maximo, which is what we use for our maintenance management. But also, it talks to other databases we use as well. So with components and defects now tagged and identified in the digital twin, direct navigation is enabled between the model, our maintenance software, which is Maximo, and our information management database, which is called PIM 360. So we can get access to pull up the data sheets, drawings, P&IDs, just by clicking on the tags that we put into the GDI model. And this has been really beneficial for my space, just in saving time. Once somebody's got it tagged up in there, you can access it again very quickly. So yeah, so the digital twin is enabling us sort of remote learning and familiarization, both internally and externally. So currently, I mean, I'm starting to use this tool for most of the work scopes that I've been involved with now. When we're planning a work scope, I use this to go in and look around and like see the bigger picture, and not having to rely on individual photos, which we used to do. So we can talk to the planning team offshore, focus in on particular areas, and then ask them to go and specify some specific actions for them by using this tool. I use this tool now for troubleshooting for various pieces of equipment, plan and replacement, valves, coolers, exchangers. We use it for helping with risk assessments. We use it for our management of change process, for assessing plant changes, doing our risk barrier reviews, and we also use it for verification of data and the condition of equipment at a point in time. So inspection, we're using the digital twin for inspection. So inspection is time consuming and labor intensive activity offshore. So with a digital twin, the data and the images captured are being used to disrupt the way we deliver offshore inspection. What has always been exclusively an offshore activity is now being supplemented and supported from onshore with remote desktop visual inspections. So here's this is another video. So this is showing the visual inspection tags that have been put in place for pieces of equipment. It's pulling up the scan. It's marked up there, visual inspection for this piece of pipe. And when concerns are identified, the offshore inspection teams are being directed to complete a more focused site inspection. This is very much a complementary inspection technique that we're using, and we're not removing personnel or reducing our inspection team presence offshore. We're just using this to support and complement and hopefully be more efficient in our inspections. It is acknowledged that the data is only 100% accurate on the day that it was captured. And our strategy will be to periodically repeat the laser scans to update and refresh the data throughout the remaining asset life. And this is being integrated into our management of change process. When we do change pieces of plant, we'll have them marked, earmarked for going and prioritising a data scan in that area to reflect the change. So through the adoption of this complementary inspection approach, we are projecting an increase in both the speed and the quantity of the inspection we will be able to achieve. Here's here's a case study that we've done regarding pipe deck penetrations. So traditionally, so the challenge was to create a register of all the deck seals. Was concerned with the condition of them, and get correctives put in place and prevent any failures of the seals. Traditionally, this would have been a register that was built by the offshore inspection team, and there's around 3,000 locations. It's quite a time-consuming process to go around and identify all of these. Then import, update the register, and then send it onshore for a data review. So the digital twin enabled us to complete a desktop inspection and data review. The locations and the registers was all populated in the digital twin, and it's fully auditable. So we've been able to give selective offshore inspection scopes. We've realised around a 2,000 hour saving in offshore time. That's about a 40% projected reduction in activity cost, and it means that we've been able to remove defects sooner and repair them sooner. So yeah, the locations and the registers are all populated in the twin, and they are fully auditable. So to recap on some of the benefits I've talked on so far. So we've got this remote learning ability for asset familiarization. It's an effective communication tool and a visual common point of reference. We're seeing efficiency gains from the enhancements of our onshore planning capability and integration of our software platforms, such as Maximo. It's given an ability to rapidly respond to emergent issues and efficiently plan routine repair and maintenance scopes. A new approach to inspection and a complementary technique that will increase the quantity of inspections we are able to achieve. So some of the efficiencies here. So it's providing efficiency for us. It's continuing to drive efficiencies by adopting the technology and changing our behaviours, how we would have traditionally planned work. It's maximising our onshore planning and work preparation, which proved really useful for our the first TAR that Serica completed just in June this year. It's also helping us prioritise our offshore labour. It's supporting us in our response to COVID, because due to our reduced POB, it's allowing us to do various preparations and engineering tasks onshore without the need to send people offshore. I would have traditionally, well, I would have went offshore maybe 4 times per year, and because of the COVID restrictions, it hasn't enabled me to do that. But using the digital twin, it's enabling me to still progress with the planning of some of the scopes that I've got in hand. One of the recent successes we had was our wellhead maintenance campaign, and our wellhead interventions engineer, he had never been on the Bruce asset, so he was able to plan and execute the wellhead maintenance campaign with the use of this tool. And I think our VP of Ops, we don't know how much it's cost us to. He won't tell us how much it's cost us to implement the software, but it's like it's paid itself back already with all of these efficiencies that we've managed to realise. So it is a continuous development project. there's a number of things that need to be done, and we're continuing to do. It's an ongoing task to populate the digital twin with tag numbers, for example, and the digital twin itself needs to be updated. Currently the frequencies around 6 months just now that we're planning and doing this to go out and take the digital scans again and update the model. We've started to use the tool for cumulative risk visualization. So when we're looking at degraded barriers on the asset, we're managing to incorporate them into the tool. So if you've got for example, you've got a defective deluge system, you're able to tag that in the model. And if there was, say, perhaps a weep or a seep from a valve gland, you're able to quickly identify that there's another risk here. The deluge system isn't performing, perhaps, and you've got a seep or a weep emitting here. So it's allowing you to visualize that and see that a lot more easily. We're continuing to integrate our existing software and links into the tool to help with efficiencies. So I've touched on our work management system, which is Maximo. We're going to be incorporating our controller work system and more of our information management in there. So you can, for example, click on piece of equipment and you're able to pull up the P&ID quickly without having to go into another bit of software, search for it, and then pull it up. So yeah, I've just watching the time there, doing not too bad. So the last few minutes, I just wanted to show a couple of things. So if I went to, I'm going to go this here. This is an area where there's a lot of valves, which you'll see, and I've been doing there's been various programs for upgrading these valves, and it's quite, you can see it's quite congested. There's all these cylinders here are the actuators for the valves, and they're coming off of the manifolds. This one has been removed, it's decommissioned. These ones are nice and bright and they're white, quite recent. So I'm using this tool to kind of quickly identify which valves are out of use, because like this one, and some of them that are an older design. I know these are an older design with discussions with the manufacturer. This end plate is welded on. This is the newer design. This is all cap screws. So just by using this tool and walking up and down this area, I'm able to start populating a register on the condition of these valves and planning the way forward. This is another scope that we're in the stages of planning. This is a glycol heat exchanger. It's a heavy piece of equipment, it weighs about 10 tons, and it's started to weep slightly. So this is it here, this box that you can see. These are all the bolts there. You can see the little arrows there. This is an indication of where we're starting to see a leak, a seep. So we're seeing a drip every couple of minutes. So we're planning on changing this piece of kit out. So, I mean, when you can zoom out here, you can kind of see the bigger picture and just how complex and difficult it is to take this 10-ton piece of equipment out of this package. You can actually click in here and you will see a bit more. So yeah, you're starting to see the flange connections here. Just see, you can see how congested it is. There's logging to be removed. All of the destruct that needs to be done to get access to get this out. It's going to be a complex job, and using this tool has been so useful for me, certainly because I can't visit the asset due to the reduced allowable personnel on board. But I've been using this tool with the planners, the lifting engineers to plan this. So yeah, talked about. So well, one thing I haven't talked about yet is just the measuring tool. So so really, it's like millimeter accurate, and so you can use this tool for just taking some measurements. That's just me taking that bit there. What's really clever about this is, so when if we just put it on that bolt head, for example, and you just measured it to just the edge of that little bracket, and if you move it just a few clicks along, and this is touching the exchanger on the back, and you can see how it just changes from like 8 centimeters to 45 centimeters. I was a bit skeptical of using this to start with for checking various things. I use it for verifying work orders. So, for example, checking a face-to-face dimension of a valve, or if we're replacing valve actuators, which are a different design and usually at different sizes, I can use this tool to verify that what we're buying, what's been proposed, is going to fit, or highlight any issues, as the case may be. So this measuring tool is something I use quite often, just even for checking how congested something is. Are we able to remove this actuator from a valve? Can we take this bit of pipe out easily? So it's helping us flag concerns early on instead of waiting to execute the work and realizing we've got a problem while we're actually carrying it out. So, and just got a couple of minutes. This is another job that we're working on. It's proven difficult to get the vendor offshore to go and to survey this. But this line's here. These are utility points, seawater utility points, and the problem is all the lines are all welded together. It's duplex pipework, and the valve condition are deteriorating. The bolts are corroding, and it's a risk. And the isolation valves further back are defective and can't provide a suitable isolation. So we're proposing to do a sort of pipe freeze on all of these points. So this tool's enabled us to go pick all the locations and see, like, the run a pipe, see what we need. Is it possible to get the pipe freezing equipment on there? Where's the best spot to site it? So this one isn't too bad, but some of the others are quite different. So I've been using this tool with our third parties to show them the job at hand. Yeah, you can see this one here. So this pipe, this is a bit different. It's a bit more difficult. There isn't the same room here between the pipe and this support. So it's been a really useful tool for this project that we're planning, getting the materials and where we're going to site all of the pipe freezes to complete an isolation. So, okay. So that is kind of my time up. And yeah, thanks for listening. And I think we've got some time left for some questions. I'll try my best to answer them.
Thank you very much, Bruce. That was very, very amazing just to see, you know, how much you've all been able to get on virtually just with the tool. You know, thank you. Thank you very much. We do have a couple of questions here. So Ollie said, have you been able to quantify how much this reduces Serica's Energy's footprint?
I guess no. I don't know if we've been able to quantify it yet, but it's certainly reducing that footprint. I mean, there's, like I touched on myself, going and visiting the asset about 4 times a year to do various scopes. There's a number of other discipline engineers who are the same as me, and just from that point of view, it's prevented, well, it's enabled us to do work from home and not need to travel offshore. There's been various scopes that's sometimes it's eliminated the need for equipment to be transported offshore by vessel to do surveys, and just getting people offshore. So I mean, sometimes some of the surveyors only need to go offshore for 2 hours to do their survey, but they could be there for like 3 days. There's the chopper flights, there's the taxis, there's all of that. So it is reducing our carbon footprint, but I don't know if anybody's quantified it. So that's all I can say about that.
Thank you very much. That's a very interesting point, because I currently do the carbon reduction emissions calculations for the Aberdeen City Council, and we just did the calculation of our work from home emissions, and it's just astonishing how much the overall carbon footprint has actually reduced just from working from home. So if you do manage to do that, you will be astonished at what you do find out. Ollie also says, what would you say are the limitations of this digital twin? Any limitations?
So from my point of view, one of the obvious limitations is it isn't live. So it is, when you're visually checking something out, it was only as good as the data on the day. So that's one of the limitations. I guess there's a bit when we do a change, say we change out a piece of equipment, it takes a little bit of time to do the document updates, update the P&ID, update the data sheets, manufacturer's info, before it's live in the system. And then we've got the 6-month frequency for going out and repeating the digital laser scan. So that's one of the limitations there. There'll be a bit of lag, so we've got to be mindful of that. If it's something really critical, and I do this, if I'm going to be spending a lot of money on a piece of equipment, I'll do the initial review with the tool, but I have still asked people to go and physically check certain things. So if there's any, that's my way around about it, is just getting somebody to go and verify and double check where I'm at, my sizes, dimensions or something. So yeah, it's limited in that way.
Okay, thank you very much. Also, it asks, do you anticipate onshore remote process control and maintenance to be something that can be incorporated in the future into the digital twin?
I believe it's something that they're actively working on, yeah, to incorporate it. I know GDI have got, that they are developing the software as well. They have got plans for just using artificial intelligence in the software and augmented reality as well. So they are looking to improve it, and we are on the journey with them for that.
Okay, thank you very much for that. There's another one from Motala Ajao, and it says, does the digital twin capture any modifications made to equipment on the asset? Example, when an equipment has been removed or replaced from the asset.
Yeah, so I guess I've kind of answered that. It gets captured when we if we removed a piece of equipment, it is a management of change process. So there is a robust process in place for that to update all control documentation. But for the model as well, we are incorporating updates to the model within our MOC process. So if we take out a heat exchanger, for example, and decommission it, the MOC will be updated. There will be an action in there to ensure that's captured in the next the laser scan to get the model updated. So there will be a bit of lag in getting it done, but there is a mechanism in place to capture it.
Okay, thank you very much for that. Another question says from Ike says, what are the main drivers to adopting a digital twin strategy for an asset, especially with respect to the asset economics, e.g. the asset, the size, the profitability?
Sorry, could you say that again? It kind of broke up a little bit.
What are the main drivers to adopting a digital twin strategy for an asset, especially with respect to asset economics? So what are the drivers?
Sorry, I don't know. I can't answer that.
That's fair enough. Oli said, is the tool able to flag up a fault, e.g. identify changes to plant automatically, or does it rely primarily on the information that is imputed?
I think it can. It depends on what you're verifying it against. I think when they are creating like a piping model, they can identify from like original isometric drawings. They can verify that against what the model scan is saying. In fact, this was actually done this week. Something flagged up that the drawings that we had in our system, there was for a piece of pipe work, and there was an 8 mil variation on it. So using the tool, it was able to pick up on some variations.
Thank you very much for all those answers. I'm just going to quickly, we have approximately 7 minutes left just to go over a few of the announcements. Once again, this is AFBE UK Scotland, the Real Projects event. My name is Tony Patukon, and I've been your background host for this. And if I can just get my screen to work. So bear with me a second. I'm not sure why it's not moving about. Okay, that's it. So we do have several of the programs under AFBE, which is the NexGen, the transition, the real projects, leadership and mentoring. We basically try to equip professional students just to understand, the challenges we face in the industries in different ways. We encourage you to try to be, find out more about AFBE. Join us. The information is there on the website. Upcoming events. So we have the England, the branch in England, and we have the Scotland branch. There's the Chess Club series, which is happening, Introduction to Negotiation and Business Wargaming. Interesting. That's Wednesday, 11th of August, and it starts at 5:30 p.m. There is the leadership team, which is in the Scotland one, being coordinated by Roy, and it's Rise Above Yourself, Believe, Feel, Succeed. And that promises to be an interesting one on Wednesday, the 4th of August. This is Real Projects, which I coordinate. The upcoming events, just watch out and look out for it. And we do have the gala, which is coming up on Thursday, the 21st of October. It promises to be a magnificent event, and you can go online and register. We do have quite a lot of people that have booked their tickets thus far. So please don't be told, don't be left out. Do go on the website and book your tickets. And these are all our handles. Follow us, like us, join us, be part of us. We would like, to hear more about, for you to hear more about what we're doing and, be a part of us.